Mann Machine 2017 SRE project. The project was basically designed this, whatever we see here. The design wasn't an issue, but the manufacturability was an issue. So developing a technique, a manufacturing technique to be able to make this part. The problem with this, the challenge was this part that we see is, by the way, is two parts, like a male female part. Here we go. This is one part of it, as you can see, and the other part is the other side. We don't kind of face backward, but they come match, male female aligned together in order to create this part. This is used in nuclear industry. So in nuclear, the tolerance is extremely sensitive. The product is ductile cast iron. As you already know, in a cast iron, during manufacturing of the cast iron, the supplier end, and because of the nature of the kind of process that they have, there is a tension built into the cast. So they bring a part into the manufacturing as you're cutting it, making a hole, milling operation. The stress is released. And that release of the stress causing this part, the tolerance of the parts, or the raised panel that you see over here, or the grooves, or the drill, or anything, any components which is machined here, go out of spec. So that was a major problem. So the question comes, how you're going to develop a manufacturing technique to machine these parts without allowing it to go out of tolerance. The tolerance of this part is half a thou. How much is a half a thou? As you already know, 1 thou is 1/1000 of an inch. Become 0.0005. Sorry, let's just all over again. 1 thou is 0.001 of an inch. Half a thou is half of that. So how you're going to manufacture these parts, both male and female parts, so together they're going to have consistently, they're going to have half a thou throughout the process. That is one. In addition, when you're putting these two parts together, the parallelism of both panels has to be, again, half a thou. And we are talking about accumulation of errors, machining errors. So if this one is half a thou, you're machining it, and the other one is half a thou, the accumulation of them become 1 thou, which is over exceeding the limit of the requested part. To do that part, to solve a problem, they had to go through a series of iteration to figure out what is the best way of doing it. They realized the best way of doing it, by the way, and not only that it creates, as they are machining, as you can see, the depth is quite depth, removing materials. As they're removing it, not only the tension is released, make the parts go out of spec. You're talking about these holes over here, the tooth over here, as well as the panel. Also, the heat generated, it caused the part to basically further expand or contract, which impact overall machining process or the tolerance going out of spec. So the best way they found that is going to work is don't go with half a thou machining, go with a quarter of a thou machining. And they do have a machining capability to go to that accuracy. So they went to a quarter of a thou for each side. This is one side, and the other side is going to have a quarter, so accumulation is going to be half, that is one. But also when you're machining it, rather than going and machining a heavy depth area, which can impact the tolerance, started with the part that kind of raised edge or raised panel that they had. Start machining here and further going and penetrating deep into the parts. That way, basically, kind of minimize impact of machining, expansion, reduction, and contraction of the parts in addition to a stress release. That was one. And leaving these type of grooves for the last, later part of the machining operation. These helped solve the problem, but it didn't completely rectify it. The next step they had to do was basically a stress and relieving process. A stress relieving process is a process is like a heat treating type operation. They send it outside to a third party and they do series of basically work on it. They call it a stress and relief process. It releases the tension within a cast iron, doesn't completely eliminate it, but it minimizes. So a stress and relieving process in conjunction with the manufacturing process that we talk about it, so which will start from the top, removing the minimal, then go further to the kind of removing the maximum material. That's it could solve the problem. That was one stage. Second stage was when they create these male female parts, which kind of at the end they create these, the finished parts. What they realize they can do to finally kind of make it work is machine, once all job is done and assembled together, machine the entire part again to the spec that they're looking for. And the machining has to go through the final machining has to go through a series of steps. First, they had to start with 200 thou removal, reducing to 150 to 100 thou, and finally at 50 thou outside finishing in order to make, they call it a semi-finishing process. So after this semi-finishing process, we talk about it went through a series of steps of 200 thou, 150, 500, and 50. When it is all done, then they send the part outside for a high solid epoxy cover, which it completes the parts to the spec they wanted. Furthermore, in order to create these parts, question is that how you're going to make these parts so from both ends, from the face and the back of it, is going to be machined. To do that one, they had to really design and develop a custom fixturing system to be able to hold the parts without interfering with the machining process. So the part that one and also the part itself should not cause any damage, dents, or mark into the parts. So the way they kind of thought is going to work, using these holes that you see at the drill as a bench, as a base point for securing the parts into the fixturing system, and also changing the position of securing points, allowing for the machining tool to go all around to complete the job. All the dimensions and the specs are going to be in the interview notes. And as always, quantify the reports and let me know if you have any questions. Thank you.